Hi, my name is Keith Dreiling. I teach in the Department of Mathematics here at Fort Hays. This is the third year that I've conducted this session for quantitative reasoning, but I just want to let you know that there's so much material that I can't really talk about just math the whole time, which is probably what you're wanting to hear. But I do want to show you a couple of resources out there, especially one resource that I think is very useful to you. If you go to the ets.org webpage, there's something called PowerPrep 2 software. And I want to highlight that as far as the math is concerned, even though it works for the other areas too, but I'll talk about the different types of things available in that website, or not only website, but when you download it to your machine. And it has a lot of what they have on ets.org, but I think it has a few extra things. And practice tests, for one, hints on what to, how to take the different types of tests, the different types of questions. And then practice tests, practice questions, along with more information about mathematics as far as the conventions of mathematics, terminology of mathematics, different areas of mathematics, all types of different things to work on. But if you go to ets.org and click on the GRE tab, in the middle of the page, you can see where it says prepare for test. And then over to the left, PowerPrep 2 software. If you go into that, there's a place to download whatever version you need. Okay. Now, I'll stop with that. I'll go to my page, to my desktop. The icon looks like this, GRE PowerPrep 2. Runs a bit slow on my machine. Let me try it again. Okay, it looks much like the ets.org webpage, but inside, what I'm looking for now off to the side we have quantitative reasoning measure. Now notice we have prepare for the test, writing measure, verbal reasoning, and so on. So I could go to any one of them, but let's go to quantitative reasoning. On this page, just telling you what to expect in this block right here. It talks about the different types of questions like arithmetic, algebra, geometry, and data analysis. So those are the main areas, and we'll see that later on in another document that I show you, that they break down the material. But off to the side on these links, introduction, and then you can see quantitative comparison, multiple choice, select one answer, multiple choice, select one or more, numeric entry, data interpretation sets, and then some other information here. I'm going to go through those links with you tonight to show you the different types of questions and then what's available to prepare, what things are available to prepare from. First type of question, quantitative comparison questions. This is going to look very similar to every page I go to as far as the types of questions. There will be a description of the types of that type of question, then the tips, and then some questions, and then with the solutions, so you can see how they reason them out. In this part of the test, quantitative comparison, you're basically comparing two quantities, A and B, and the choices on this part of the test will be that quantity A is greater, quantity B is greater, the two quantities are equal, or you can't determine which one is greater. And those are the options you'll have throughout those types of questions. The tips that they give you, and these will change according to the type of question, become familiar with the answer choices. Avoid unnecessary computation. Sometimes you can estimate well enough or see it reason out very quickly and not take time calculating everything. Remember that geometric figures are not drawn to scale. So don't go by the measurements that, or the lengths that they give you in segments. Go by what the information in the problem. Plug in numbers. This can work very well just plugging in numbers if it's some type of an expression, and you plug in values and see which comes up bigger or smaller, but that can take a lot of time. So be careful of doing that. Also, you want to make sure you put in a variety of numbers, like positives, negatives, zero, fractions, large numbers, small numbers, just a variety to see what's coming up. Instead of just putting one set of numbers and making a decision, it may change. For example, in one case, one number might be bigger than the other, or one A might be bigger than B, and if you put a different size number, it might be the opposite. Well, in that case, you can't tell which one's bigger or smaller. You get conflicting information. And then simplify the comparison. For example, algebraically. Then, like I said, after you go through the tips, there are sample questions. And I want to run through some of the questions they have. So this is the content that we'll be talking about, just varied content. Here's what the questions could look like. Compare quantity A and quantity B using additional information centered over two quantities if such information is given, and select one of the four answer choices, and the same four I gave you a little while ago. Here's a possible question. Quantity A, the least prime number greater than 24. Quantity B, the greatest prime number less than 28. Which one is greater? Now, if you can work through the problem, that's great, but then if you can't, or if you want to check your answer, look down below and they give you an explanation. Here's what they say. Their explanation says, for the integers greater than 24, note that 25, 26, 27, and 28 are not prime numbers. They're numbers that can be divided by other values than one of themselves. But 29 is a prime number, as are 31 and so on. So 29 is the least prime number greater than 24. So that's the value for quantity A. For the integers less than 28, note that 27, 26, 25, and 24 are not prime, but 23 is. So the quantity for site B is 23. Notice that 28 is greater than 23, so A is greater than quantity B. That's the typical, that's one of the types of questions you could be looking at. The second question, Lionel is younger than Maria. Quantity A is twice Lionel's age and quantity B is Maria's age. In this case, they using just some values, if Lionel's age is 6 years old and Maria's is 10, then quantity A is greater because twice his age would be 12. But if Lionel's age is 4 and hers is 10, then twice his age is only 8, so quantity B would be greater in that case. Because you're getting conflicting results, you can't tell which one's greater. Or it's not consistent, one's always greater than the other one. So letter D would be the greatest, or the best answer. And the third question, dealing with percentages, quantity A is 54% of 360 and quantity B is 150. Instead of calculating 54% of 360, just think of what half of 360 is. And then think of this value being a little more than that. So half of 360 is 180. 54% must be a little greater than 180. So we're comparing 180 against 150. Quantity A must be greater. And geometry question, just to show you about the length idea. We want to know if PS is greater than SR, or how PS and SR compare. Notice again that lengths are not, or this drawing is not to scale. So when we look at this drawing, it says that the information given to us is that PQ and PR are congruent to each other, or equal to each other. We also know that S is between P and R, so we have the lengths of PS and SR. But in their explanation, they say we don't have enough information to compare those two values, and we can't measure them because everything's not drawn to scale. So we can't measure them. So in this case, it's hard to tell. Well, we have a couple of situations that could be true. From the information they gave us, that PQ and PR are congruent to each other, S could be anywhere on that side. not necessarily where they drew it. So we don't know if PS is greater than SR or smaller than. So in that case, again, choice D is the best answer. Let me stop with that question for right now. Do you have any questions on that type of problem? Comparing quantities.
So the way they draw is not exactly what they mean, right?
Right. The way they drew that, the first picture up here is just an idea of what the situation is, but it's not to scale. So if you measured those lengths, if you measured them, you probably would think they're equal. But from the information given in the problem, we don't know where that point S actually is. It could be anywhere along that side. Here are two possibilities. If they gave you other information, it might have identified which one would be longer, but not in this case. So don't go by the way they look, go by the information. Other questions on this part of the test, or these types of questions. Quantitative comparison. The second type of problem is multiple choice, select one answer. And again, just like I said before, you're going to see the same type of information on each of these pages. Tips for answering: use the fact that the answer is there. If your answer is not there, if your answer is not showing up, something must have gone wrong in what you did somehow. Calculation, interpretation, whatever it was. So go back and look at the problem again. Examine the answer choices. In some questions, you're asked exactly which of the choices has a certain property. In other questions, I was actually getting ahead of myself. In other questions, you might be able to approximate. You don't have to go through all of the math. You can probably reason out which one is the best choice. Back to examine the answer choices. You may be able to consider the relationship between them, or you can substitute the choices, substitute the values back in. But like I said, that can be time consuming. So let's look at some possible questions. Again, pay attention. It says select a single answer choice. If 5x plus 32 equals 4 minus 2x, what's the value of x? Well, in this case, we could plug the values in, or we can solve algebraically, which is probably the fastest way of doing that. They said that they did solve it algebraically. They added 2x to both sides and subtracted 32 from both sides to get 7x equals negative 28, and divided by 7, so x equals negative 4. Had you had trouble knowing how to solve that, you can plug in the values until you find the one that's true. Problem 2, which of the following numbers is farthest from the number 1 on the number line? Looking at the choices, the circled choices they have, which one's the farthest? You can pretty much measure the difference or count out to the value. You can see that negative 5, 0, and 5 are not the farthest. But between negative 10 and 10, negative 10 is a little bit farther away. And it's 11, if you count it, it'd be 11 units away compared to 9 units away. This problem, if you try to graph it, or graph all the choices, it could take quite a while to do that, as far as more than just 30 seconds or whatever to get that done. But if you look at the equation they gave you, absolute value of 2x plus 4 is being graphed. It's this V line. That 2x, if you know much about algebra, you'll know that's the 2 is the slope. Actually, 2 on one side or negative 2 on the other side. So we have the slope given to us. When you look at the choices, they have, for example, x minus 2, you have a y-intercept of negative 2. That will intersect the y-axis down at negative 2. So we're down here. But the slope is only 1. The slope's not as steep as the slope of the V line, so there's no way it's ever going to intersect. Same thing with x plus 3. Even though it intersects up here, that line only has a slope of 1, so it's not going to be as steep either. It's not going to intersect that V line. 2x minus 2, well, now we have the same slope of 2x that we do up here. 2x minus 2 would intersect the graph down here at negative 2, but it has the same slope, so that side's going to run parallel. Same thing with the next one, 2x plus 3. Even though it intersects up here at 3, it'll have the same slope, so they'll be running parallel to that, never intersect. But the 3x minus 2, even though it intersects way down here, the slope of 3 is steeper than the slope of 2. Eventually, it's going to intersect. Now, even reasoning, if you know the slopes very quickly and you know those relationships, the question's pretty fast. You know, I took longer than hopefully it would have taken. However, if you know how to graph or plug some values in, you might be able to tell if they intersect or not, but that could be time consuming to do that. So the relationship of the slope, if you know slope and intercept, that question can be pretty quick. And all I did was really looked at the slope and saw that the slope would eventually, or for the one of them, was steeper than the original problem. Problem 4, a car got 33 miles per gallon using gasoline that cost $2.95 per gallon. Approximately what was the cost in dollars of the gasoline used in driving the car 350 miles? Notice they go through, when you look through the choices, notice they're somewhat far apart. You know, you're not looking at cents, so there might be some estimation that can be done. They said, in looking at the problem, the car used 350 divided by 33 gallons of gasoline. So that's going to be, what, about 10 or so, and we're multiplying that by 295, by about 3. So it looks like we're multiplying 10 by about 3 to get about 30. So 30 is the closest choice to the ones that are up there. However, if you did divide out and multiply, you're going to get 31.287, which is still close to the 30. And problem 5, dealing with probability. A jar contains 60 jelly beans, 22 white, 18 green, 11 yellow, 5 red, 4 purple. If jelly bean is to be chosen at random, what's the probability that the jelly bean will be neither red nor purple? Well, if you count up the ones that aren't red or purple, you'll get the total number of 51. Or if you count the ones that are red or purple, you have 9 of those. Out of 60, 9 are red or purple, but the other 51 aren't. So you have 51 divided by 60, you get 0.85. Questions on those types of problems? Basically multiple choice. Select one answer. Yes?
Will the question specify if only one answer is needed?
Yeah. They should be very clear on that. I believe that when you look at the directions here and we look at the next one, it should specify. In fact, it might specify exactly how many answers you want, or select all that are possible. So we'll see some difference in language on those. Any other questions on the multiple choice part, selecting one answer? Okay, selecting more than one answer. And again, here's the description at the top. The tips for answering. Note whether you are asked to indicate a specific number of answer choices or all that apply. And so it should be fairly clear. Should be very clear. In some questions that involve conditions that limit the possible values of numerical answer choices, it may be efficient to determine the least and or greatest possible value to eliminate some of the choices and narrow down the ones that are even possible. Avoid lengthy calculations by recognizing continuing numerical patterns. Okay, let's look at the direction just to see what that looks like. Select one or more answer choices according to the specified question directions. So this is for the whole part of the test here, or for the questions I have here. If the question does not specify how many answer choices to select all that apply. The correct answer may be just one of the choices or as many of the choices depending on the question. No credit is given unless you select all of the correct choices and no other choices. Okay, so no partial credit on getting some of them right, some wrong. If the question specifies how many answer choices to select exactly that number of choices. And no more, no less. So looking at the types of problems, or sample problems. Which two of the following numbers have a product that is between -1 and 0? So again, which two numbers? So we're picking between A, B, C, and D, or two of those four. Looking at the different choices, between -1 and 0, you're not going to get that from 20 times 10, or -20 times -10, or the 2 to the -4th, 3 to the -2nd. If you think about what those values represent, 2 times 2 times 2, 116. And 3 to the negative second is the same as 1 over 3 squared, 1/9. So you're looking at those decimal values, those fractional values. And you probably, well, if you multiply those two values together, they're both positive, you're going to get a number greater than 0. So we can narrow down the pairs that we can't have together. You know, A and B can't be together, C and D can't be together. But if we start mixing and matching, here's what they say. The product of a pair must be negative, so we need a positive times a negative. The choices are negative 20 times 2 to the negative fourth, negative 20 times 3 to the negative second, negative 10 times 2 to the negative fourth, and negative 10 times 3 to the negative second. They go through looking at some of the different choices. The negative 20 divided by 2 to the fourth, negative 20 over 16 is going to be something past negative 1 on the negative side, negative 1 point something, so that's out. Negative 20 over 3 squared is negative 20 over 9, which is also negative 2 point something, so that's out. But negative 10 over 2 to the fourth, negative 10 over 16 is its decimal point something, 0 point something in the negative side, so that must be the correct choice. We need to choose B and C as the two choices for that problem. Problem 2. Which of the following integers are multiples of both 2 and 3? Indicate all such integers. Give every answer possible, no extra, or every correct answer and no others. Their explanation goes through how we could identify, for example, the evens first, the numbers that divide by 2, like 8, 12, 18, and 36. So we're down to those choices. And then see which ones also divide by 3. And of those choices, 12 does, 18 does, and 36 does. So C, D, and F would be the three choices that we mark. The next one is more involved. We can look at their explanation, see if it makes sense. We can also do some kind of reasoning for part of it. This is one where we can narrow down the greatest and least values, maybe narrow down or at least eliminate some choices. Each employee of a certain company is either in either Department X or Department Y, and there are more than twice as many employees in Department X as in Department Y. The average, the arithmetic mean salary is $25,000 for employees in Department X and $35,000 for employees in Department Y. Which of the following amounts could be the average salary for all the employees in the company? Well, looking at the choices, the average has to fall between the 25,000 and 35,000, but all of those values do fall between there, right? So that really didn't help. Also, there are twice as many employees that earn 25,000 as 35,000, so you'd think that the average would probably be closer to the 25,000. Now, going down a little further in their explanation, since you're told that there are more employees with a lower average salary, the salary of all employees must be less than the average of 25,000 and 35,000, which is 30,000. So it must be less than that. So now we've at least narrowed down that just the value is less than 30,000. If there were exactly twice as many employees as in Department X as Department Y, then the average salary for all the employees would be, to the nearest dollar, the following weighted mean. And notice what they did is they just chose 2 employees for X and 1 employee for Department Y. So they gave about the simplest case they could. They just made up numbers, but we have twice as many employees. And when they did that calculation, they had 2 times 25,000 plus 1 times 35,000 divided by the 3 employees, and they get 28,333. Since there are more than twice as many employees in Department X than is in Y, the actual salary must be even closer to 25,000 on the lower end, below 28,333, which means that maybe it is 28,000 and maybe it's 26,000. So they just kept narrowing down the choices from reasoning out, well, basically the average, then going to the weighted average, and because of the language of more than twice as many, they could reason down even more so. Okay, that was the last one I wanted to talk about in that section. So that was the section on multiple choice. select one or more answers. Pretty much answer what you asked before. Any other questions on these types of questions? Numeric entry questions. Again, a description, and then tips for answering. Make sure you answer the question that is asked. Sometimes you have labels for the answers, so you should know how to answer, what they're looking for. Make sure you pay attention to that. If you're asked to round your answer, make sure that you round to the required degree of accuracy, a certain number of decimal places, or to the nearest unit, or whatever they ask. And examine your answer to see if it's reasonable with respect to the information given. Here are some sample questions. Notice that in this part for the directions, they have a whole block of instructions up there for you. They tell you how to type in the number. Click on the box, type in the number. To erase the number, use the backspace key. For a negative sign, type a hyphen. For a decimal point, a period. To remove a negative sign, type the hyphen again, it'll disappear. The number will remain. The transfer display button on the calculator will transfer the calculator display to the answer box. There's a calculator built in that you may use, and I'll show you that calculator here in a little while. Equivalent forms of the correct answer, such as 2.5, 2.50, and so on, are all correct. Enter the exact answer unless the question asks you to round your answer. To enter a fraction, type the numerator and the denominator in the respective boxes using the keyboard. And again, they give you some information about negative sign and so on. Some sample questions. 1 pen costs 25 cents and one marker costs 35 cents. At those prices, what is the total cost of 18 pence and 100 markers? And basically we can do the multiplication for each of those. 18 pence times 25 cents, 100 markers times 35 cents, and we get $39.50. We want to type in $39.50. It says equivalent decimals such as 39.5, 39.500, and so on are all correct. Even though we don't normally type dollars and cents like that, they would not count that wrong. The second question, a rectangle R has a length 30 and a width 10, and square S has length 5. The perimeter of S is what fraction of the perimeter of R? Well, the perimeter of S would be 5 plus 5 plus 5 plus 5, or 4 times 5 for 20. And the perimeter for the rectangle would be 2 30s and 2 10s added together, so it's 80. So the fraction we have is 20 over 80. Now if we type that in, it's correct, but if we reduced it down to 2/8 or 1/4 or something equivalent, it would count that correct also. So 20/80ths or something equivalent to it. The next question, results of a used car auction. They give us information on small cars and large cars, the number of cars offered, number of cars sold, projected sales total for cars offered in thousands, and actual sales total in thousands. So make sure we pay attention to that information. For the large cars sold at auction, that are summarized in the table above, what is the average sale price per car? Large cars sold, so we have the 20 cars sold, and the actual sales total was $120,000. So we're dividing the 120,000 by 20. You can see the calculation here to get 6,000, not just 60 or 6 if we divide it out, the 120 over 20. So we had $6,000. Correct answer is 6,000. Note that the comma in 6,000 will appear automatically for you, so we don't have to put that in. Questions on those types of problems? Those were numeric entry problems. The next type of question is data interpretation sets. Again, we have a description, the tips for answering, scan the data presentation briefly to see what it's about, but don't spend time studying all the information in detail, because even in the last problem we had a lot of information, but we only used a couple of numbers from that whole table. So we could have an idea what the table says, but don't study too carefully. Bar graphs and circle graphs, as well as other graphical displays of data, are drawn to scale. That's different than the geometry. They are drawn to scale because they want you to interpret things from those graphs. The questions are to be answered only on the basis of the data presented, everyday facts such as the number of days in a year, and your knowledge of mathematics. So don't bring other information in besides what's true in mathematics or facts that, well-known facts. Questions 1 to 3 are based on this data. Okay, looking at the table, we have different stores, P, Q, R, S, T. The percent change from 2006 to 2007, and then the percent change from 2007 to 2008. So these are percentages that they're giving us. If the dollar amount of sales at store P was $800,000 for 2006, what was the dollar amount of sales at the store for 2008? And notice in store P, there was a 10% change the first year, and then a negative 10% change the next year. But don't assume that those percents are going to cancel each other out for the same amount to begin with, or as to get the same amount that we began with. If we do a calculation by adding 10% more to 800,000, if we multiply by 10%, we're going to get $80,000 to add it to that $800,000. So at the end of the first year, we have $880,000. If we take 10% of that, we're going to have $88,000 to subtract from that, and we're down to $792,000. So it's choice B. Now, could we have maybe estimated that one without calculating? Well, at least we could have eliminated some choices that wouldn't make sense. We added 10%, then we took 10% of a bigger number, which means we're subtracting more. So we should have less money, less sales tax after the second year that we started with. So we could reason in some of that. At store T, the dollar amount of sales for 2007 was what percent of the dollar amount of sales for 2008? For store T, we had 17 and negative 8. Oh, I guess they're just asking about 2007 to 2008. We had if we set this up in an equation form, it says if the total dollar, if A is the dollar amount of sales at store T for 2007, then 8% of that is 0.08A. And that's the amount decreased from 2007 to 2008. So if we subtract the amount minus the 8%, we have 92%, 0.92A. Therefore, the desired percent to be obtained by dividing the 0.92A, dividing A by 0.92A, and here they show that here where the A's cancel, we're left with 1 divided by 0.92 and we get 1.0869. So it's about 1.08.7. They're asking us to answer to the nearest 0.1%, nearest tenth of a percent. So there they specified how far they wanted it. I want to stop with that question. Questions on data interpretation. Okay, like I said, I'm not covering much content tonight because there's such a varied amount of content, but at least you can see the different types of questions that are available in the system, give me an idea of how to answer those types of questions with explanations. A few more things I want to show you though. Remember I said there's a calculator, and they show what the calculator looks like, and then they give an explanation of how to use the calculator. Remember we talked about transfer display a little while ago? There's some choices for that too, or a button for that. But it gives you an explanation of how to use their calculator. It talks about all the buttons and so on. So you may want to become familiar with that. Yes?
So the on-screen calculator is the only one you're allowed to use, not a physical one?
Let me see. I don't remember what it said about using other calculators or not. Anybody read anything about that?
I don't think we are allowed to bring anything else into the test center.
Anything on, not even calculators? That's what I thought, but I'm not sure of that.
Yeah, I wasn't allowed one 2 years ago.
Okay.
Little place where
Okay.
you can go
Thank
and
you.
stuff.
Okay.
And I think you're allowed a pencil and maybe a water bottle. But
But nothing else?
I don't think you're allowed
Yeah.
anything else.
Yeah, I didn't think they did, but I couldn't remember for sure. So it would be very wise to learn this calculator. There are, like I said before, there are a lot of different types of questions, a lot of different types of mathematics to be aware of for the test. Over here it has math review. I clicked on that and it asks, or it has a place where I can download that as a PDF. Now notice this is 102 pages long, so we're not going to cover all of that, but I just want to point out a few things here. Okay, in the table of contents, look at all, remember the four main types of problems, or the content types of problems? We have arithmetic, notice the different types of questions, and then when we get down with explanations about all of this, then they have some exercises for you and the answers. So if you want to practice some, just on paper, some problems, there are some here for you to practice those concepts. In algebra, the same setup. Here are the different concepts, and then exercises and answers. Geometry, same thing, and data analysis. Here's what it looks like. Here's the explanation for arithmetic, explanation on integers, talking about divisibility, least common multiple, greatest common factor, and all those types of things. I just want to scroll through a little further. Some of the terminology, notice they boldface all the terminology that you'll need. Reciprocal, mixed number, exponent, base. Let me continue down a little further. The inequality symbols. I'm going to go down here. After the explanation, here are some exercises if you want to practice up on some of the topics. Not necessarily in the form they're going to be in the questions on the test, but as far as content itself. So go in here, you can answer the questions, and then a few pages later, we have the answers to those questions. So it's a pretty nice way of at least reviewing some of the content that's there. Let's see. And then the last thing I want to show you is mathematical conventions. For that link, we also can download the PDF for that. This is only 11 pages long, but by mathematical conventions, what we mean are the rules that we follow in mathematics, the accepted practices, how we write things, how we regard the different rules, how we have order operations and things like that. So here it talks about how we do the different things in mathematics. Looking at the symbols, x is less than or equal to y, x does not equal y, x is approximately equal to y, and so on. So you can see some of the terminology, some of the symbolism, perpendicular, parallel, the square roots, the absolute values, those different types of things. Geometry, some of the terms associated with geometry. Area, distance, similar triangles, geometric figures, different types of angles. Graph, coordinate systems. And at the end of their explanations, we should have, I think I skipped over it. Oh no, these are conventions, not practice problems. But anyway, there's some more information there. Become familiar with accepted practices. questions on the different items with the Power Prep 2 software?
I have a question.
Yes.
As for me, the most difficult part in the terms that in English,
Yeah.
we can find the definition of the terms. Like
And the last two links, the math review and the mathematical conventions, probably has the terminology you need. So those would be good places to look for that. Also, in thinking about the content, like I said, there's no way I can talk about content and cover everything. But what I recommend that you do is go through practice materials and write down some things that you have questions on. And then come see somebody up in the math department, see our tutors. A few years ago, I had a student that came in. Once he found specifics that he had questions on, he just came in for those questions. He knew of everything else. So I was able to focus on his questions alone. And that works out fairly well. Any other questions about the Power Prep 2 software? Like I said, it's a free. Oh, the other thing I mentioned something about practice tests. I believe that when you get in here, if you download this, that there's a place for practice testing. Let's see. I can't find the link right now. There's a place where you can get into a practice test. And I believe there are, I think it depends on how it's downloaded, but I think you have 2 practice tests available to you that you can get into and practice. One of them I think you can practice as an untimed test, just to take, and the other one can be timed. And so I would suggest doing that to put yourself in somewhat of a testing situation and see how you do. But that's another neat thing about the Power Prep software.
They'll email you the link once you sign up.
Oh, for Power Prep 2 also?
Yeah.
Okay, good. Also, young lady here had mentioned to me a while ago that she has apps on her phone that are free apps, and just did a search on GRE Prep, and you'll see several apps that you can download and use those too for preparation. So there are things out there. I think especially the Power Prep 2, which is what I was most familiar with, I think it's a neat way of preparing for the test. They give you a lot of information and some good practice problems, and then also practice tests and so on. Any other questions or comments? If you have specific questions that you want to stick around for later, I'll be around here for a little while longer. Otherwise, I think we're done.